I'm going to try also recording this in here. I've got a record button now. There are 30 questions on the test. And let's see, today is 9/9/19 IA review. We are reviewing for the interim for physical science today. And just a couple little reminders about parking it. Let's see, you're supposed to be logging into Clever Daily and following links on there and on your Canvas calendar to attend classes and complete assignments. And just remember to keep our chat box limited to the content of the lesson and always be respectful and courteous. All right, so there's where you can click on those three little lines. Download files by clicking on my attachments. Look at files on the whiteboard. I haven't released today's PowerPoint yet, but after I go over it, then I'll release it so that you can page through it and get back to anything that you may have missed. All right, so give me a green check if you are ready to check your review, and a red X if you are not. Look at all those green checks. And if you all know Via from last year, that is her cat there. All right, looks like we are ready to go pretty much. I don't see any red X's. All right, I did want to just remind you about academic integrity, that you will not copy or redistribute any part of the assessment. You're going to take it by yourself, and you're only going to use your blank periodic table and your calculator, of course, and that will be it. Oh, any questions about academic integrity? All right, Kaher. Yeah, this is a long class. So I think we'll be before, I think we'll be done before the hour and a half. I have a Mac, I don't have Word. Oh, good question. Ariel, do you want me to, can you print it out and then write on it and scan it? Yeah, you can certainly do that, or you can just type the answers in whatever you think, whatever Word kind of document you have on Mac. I don't have a Mac, so I don't know. And then you can just copy it and paste it into the Dropbox. All right, Kaher, and what part do you sing? Oh, okay, excellent. Ava? Yeah, I understand if you guys have a need to leave a few minutes early. It's not going to take an hour and a half to go through the review sheet. That's fine. All right, let me just get that going. Let's see. All right, so number one, I think I'll put these down on the whiteboard and then you all can write on them. I like that. I really like having you all write on them. Hey, yes, got to keep practicing to get to first. Let me give you guys some whiteboard tools. And let me lock up the eraser. All right, there you go. So let's put the answers on there. And I'll check your work and you can check your work. Oh, and I gave you a nice little hint down at the bottom. I'm going to get rid of my camera. Your protons minus your electrons will give you your charge. And there we go, +3 for B -1 for A, and +1 for C. Nice job, guys. Back. The answer is back. All right. If you need me to stop and go back to any of these, just let me know. I think we can do this one in the chat. Or if someone wants to pick up the mic, I'm good with you picking up the mic too. So atoms with a positive net charge. Let's go back and look. Here's our one with a positive net charge, right? And that was B. It had 31 protons and only 28 electrons. So in order to get that positive charge, it must have lost electrons. So atoms with a positive charge lose electrons. And then atoms with a negative charge, what are they going to do? Right, they're going to gain electrons. All right, remember we can't ever change the number of protons. If you do, then you're radioactive. So. And y'all, if I'm going too fast, you can always give me a red X, and that will make me stop as well. So I've got my participant screen up over here on my other screen, so I can see your green checks versus red X's. Ooh, this one goes on the board. Oop, oop. I'm gonna put these on separate boards. We haven't figured out yet how you guys can page through the group whiteboard, but anyway. Oh no, gear and refresh. If you can't hear, do your gear and refresh. Emily, at the end, I'll give you the ability to page through all the pages and get back to 1 and 2. No problem. You bet. All right, so let's fill this one in on the board. And just a reminder, I think I'll use red today since we're reviewing. That little number at the end is the mass. Like lithium's mass is going to be 6. So yes, lithium has 3 protons. That's the atomic number on your periodic table. Hopefully you all have your periodic table. 3 protons, 3 neutrons. Yep, because there's 6 mass, so 3 plus 3 has to equal 6. And 3 electrons. These are all neutrals, so it's all going to be equal to the protons. Exactly, Ariel, or Ace. It sounded weird calling you Ariel. Anyway, the atomic number is the protons. That is, the number on the periodic table. I don't know if y'all can see that. And then that's going to be equal to the number of electrons in a neutral atom. So how about oxygen? Oh, good. Someone's starting oxygen. Can I get another volunteer to fill in helium? Oxygen has 8. Go for it, Zuleika. Eight electrons. Oh, thank you. Those are all good. Helium has 2 protons. That is correct. 2 neutrons and 2 electrons. And y'all, this was totally not planned to have these 333, 888, 222. That just was a random fluke. They don't always come out the same. Like if that was oxygen 18, would have been 8, 10, and 8. So my bad on that one. Yeah, and there's my fluke picture. All right, label the dots. Put this one down for you to label. Which one is the proton, which one is the neutron, and which one is the electron? Yeah, I like my teacher shark meme or Bitmoji. Ooh, all right. So, I mean, it's hard to tell the red from the gray. Both could be a neutron, both could be a proton. Generally, the neutrons are the more neutral color, the gray, but there's really no way to tell them apart. They aren't actually colored like that in real life. If you saw a proton, it would not be red. So, yeah, as long as neutrons in one and protons in the other one, then we're good to go. Yep, so either way is fine. I made mine the way that Fett had it, with the orange being the proton. All right, element names. I think we can do this one in the chat. All right, which one is helium? The first one. And can we add in the mass, helium dash, and then a number? All right, so we got 4 and 2. What is the mass of that helium? Yeah, it's going to be 4 because there are 4 subatomic particles there in the nucleus. Nucleus is mass. Yes, the neutrons and the protons. How about our second element over here, the purple one? Yep, beryllium. And the mass, what do y'all think? Is that 8 in there? 1, 2, 3, 4. I can just check because I got the answer on the next one. You were wrong. Oh, but that's on the periodic table. That's the average atomic mass. If you averaged all the isotopes of beryllium, the average mass would be the 9.01. Yeah, Kaher, this is an isotope. This is beryllium 8. So you're not wrong. It's just different than this particular isotope. So if you have it written with a dash and then a number, that's the specific isotope. If you don't have that -8, then you look on the periodic table for the average atomic mass. Yes. Exactly. All right, number 6. Ooh, okay, I'm put this on. Oh, wait. First I have to move it down there. I'll get used to it eventually, I promise. Oh, for a second there, I thought it was going to spell chair, but then I realized there's no R as a choice, but that would have been cool. Noble gases are actually, let's see, noble gases, we've got I and F. So we've got light blue and teal. And I wrote that this one was teal on your review sheet, right? So I believe that noble gases are I for teal, yes. Because I didn't know if you guys would be able to tell those two apart. And also I put the choices in the same order that the colors went across. So I was hoping that would help. All right, so we've got the alkaline metals are red, check. The alkaline earth metals are orange, check. Transition metals are white, check. Halogens are purple, the best color. Ooh, we got two choices for halogens. Halogens are the purple one. Yeah, we agree on the favorite color. There is, it's right here. And then the noble gases are teal. All right, let me show you the, there we go. It's a chabe. No, I can't put it in Canvas because y'all are the first, y'all are the first group to go over this. I don't want to post it and then have everyone else just look at it before they test. But I will have it available for you to look at here. I will have it available as soon as we finish going through it, then you can page through it all you want. The key means it's the answer key. It's so I can easily tell which slides have the answers on them and which ones have the questions on them. It's that visual cue. I love visual cues, so that's on there for me. If you want to think about it as the key to your car, and it's not really a car key, it's more of a house key. All right, which of the following are false? Your key to learning. There you go, Sky. That's perfect. So which statements are false? All right, Zuleika's going with D. Ariel's going with C. D and C, because it could be more than one. Michaela's going with D. Gabriel C. Jasmine C. Via, you're throwing A in there. Oh, okay. Oh, a CD. I got it. A CD. It says which of the following are false. So just by the wording, and look, my little goblin thing is telling you there may be more than one. There are more than one. And you guys are right. It's C and D. Yes, my blob, my hinter blob. Oh, yeah. Oh, you guys are hilarious. All right, so C and D. The nonmetals are mostly gases, but bramine's a liquid and a couple of them are solids down there. Sure, Ace. Yeah, I have been releasing the key to those who submitted the study guide. I totally forgot to look for those this morning, but some people wanted to study before they had the review session. So I probably won't do that again, but I mean, if you want it, I can always send it. Yeah, no problem. Okay, number 8. Which best describes metals? All right, so as soon as things go into the Dropbox, I'll release the key. Well, I just attach it when I write, whatever I write on there. Okay, so we're going with B. Anyone else want to chime in? I've got 3 Bs out of 23 of you. How about the other 20? Oh, 4, 5. I think A can go, yeah, because carbon's not metal and it's not transparent. All right, sulfur is not a metal because it's an insulator. Metals are good conductors. Yep, and there's little Umbra's comment. Okay. Yeah, metals are malleable. I'm going to put this one on the whiteboard so you guys can circle the answers. And there's a nice picture of some platinum crystals, sulfur, and silicon. And metalloids are definitely opaque. That means that no light can pass through. They are solid at room temperature as well. And they're like nonmetals because they are brittle. Very nice. Well, to make glass is silicon dioxide. It's a compound, and you can see through it because of the way it's formed. It's formed with a random pattern, and that allows it to transmit the light through it. And we're going to learn about those in just a couple weeks when we do compounds. All right, moving on to number 10. Elements that share the most characteristics are those within the same. All right, group. Yeah, group. What is another name for groups? Yeah, the families. Definitely. Columns are good. But families, like you and your family members have all the same characteristics, just like the groups on the periodic table. They're kind of like families. Number 11, using your periodic table, which element is most similar to aluminum? All right, 20 more. Can I get 20 more opinions? Excellent, excellent. They are coming in. All right. And yeah, welcome Sahir, Riley, Joseph, Hannah T. Welcome Danielle and Avery. And Ava, I think you guys came in after I did the green check thing. Via. C is correct. Y. Yes, they are in the same family, and you knew that because you are smart. But remember, smartness is not like something Generally, you can be born with intelligence, but you can gain it too by practicing using your brain. You get smarter and smarter every time you learn something new. All right, number 12, which metallic group is considered most reactive? Which metallic group is most reactive? Oh, there we go. I got my hand up. It's number 1. It is red. So the alkali metals is the most reactive metallic group. Which non-metallic group is most reactive? And ACE, I'm not sure you get less metallic as you move across the periodic table, but you do get more valence electrons. And the more valence electrons you have, the less reactive it is until you get to the middle. Oh, well, I mean, kind of like when you get over here on the right-hand side of the periodic table, that's true, that the further across you go, the less metallic it becomes. But, I mean, they're all metals, you know, in here. Yeah, and I see her point with that. And that's definitely true when you get over into the metalloid part. This is called the P block. So I would go with that. That's all right. Which group is most stable? The P, capital P block. Yes, group 18 is the most stable, definitely. All right, so we got DCA for that one. DCA. Dismiss 8th period. All right, match the following with the correct state of matter. Oh, it did kind of sound like that. Do you like my moving particles? I don't know if it's sulfur. I just found a picture of a solid. Yeah. Are you having, Ace, are you having trouble with Mac? Oh, okay. That's not a problem. So notice how the particles are stuck in this crystalline form. The crystalline form is kind of hard to see on here, but they are stuck in place. If it was a gas, they'd be like going like, oh, over the place, you know, and they're not. They're just sitting there and they're vibrating. It's a GIF, yeah. I figured out that you can put them in the PowerPoint and they show up on here. All right, so B was liquid, C was gas, and A was a solid. Oh, it was spread out though? Let me go back. It was spread out because they're just zoomed way in. But yeah, I got your point. I wish that, yeah, I see that, your point. I wish the blue lines were darker that show it's crystalline. Sure, Ace. Yes, there should be. I mean, last year I know we got it for free. Ask your FSL about how to get that and see what they say. Because last year I know it was free for everybody. You know, and Ariel, that's fine. All right. Oh, here we go. And you guys had asked for additional help with half-life. So here we are on our half-life question. The half-life of actinium-227. Ooh, there's the mass. Remember, that's an isotope, and there's the mass. Anyway, back to this. The half-life is 22 years. How long would it take for 10 grams to decay until there's only 2.5 grams left? Okay, so first, I'm just going to show you the quick way to use your hand to do this question. All right, so we're going to start with 0 half-lives, right? We want to know until there's 2.5 grams left. So right now I have 10 grams, right? That's what I'm starting with. And I'm going to cut it in half, right? 5 is 1 half-life. And then 2.5 is the second half-life, right? So that's 2 half-lives, and each half-life is 22 years. So that's 22 years, 44 years. I feel like it should have little eyes on it, the dog. Okay, so there is that equation that I don't remember. Let me think about it. It was the amount left. It would have been the 2.5 equals 10 times a half raised to an unknown power. And X would be the number of half-lives. Once you found out X, then you'd have to multiply it by 22. Yeah, you can do it on the chart. Okay, so let's do it on the chart, and then I'll go through the equation. Okay, so half-lives, we're gonna start with 0. That means at the beginning, no time has gone by, and we started out with 10 grams of stuff. All right, and then after 1 half-life, we know that 22 years has gone by, and there's 5 grams left because it gets cut in half. The mass every time gets cut in half. After 2 half-lives, now another 22 years has gone by, so now we're up to 44 years. And the mass is cut in half again, so we're at 2.5 grams. Oh, my dot keeps disappearing. Okay. And then after a 3rd half-life, just in case in another problem you'd have to go further, another 22 years has gone by. So we're at 66 years now. And half is left, so 1.25. Oh, my dot disappeared again. That's 3 times it's disappeared. And then I can look at my question, and the question asked was, let's see, how long would it take, so that's our time, until there's 2.5 grams left. So I find my 2.5 grams. You can write this however you'd like. So there's our answer. And I'm going to clear out the checks. And then I'm going to ask you all to give me a green check when you're ready to move on. Okay. And woo, awesome. All right, someone wanted me to talk about this equation up at the top. So I'm going to do that real quick. So if we take this equation up here, and basically you want to try to get X like by itself. So we would divide both sides by 10. Let me change my color. I like to switch colors when I do math. So I'm going to divide both sides by 10. That way you can tell the different steps. 2.5 divided by 10 is 1/4. We want a fraction so that we can solve for x on the other side. And let's see. So Ace, you wanted to see how to do this with the equation. Are you following me there that far? Okay. And then 1/2 raised to what power will give you 1/4? 2. Okay, so we have 2 half-lives, right? And then we multiply that by the 22 to get our time, which would have been 44. Oh, I'm so bad at writing with the mouse. Oh. Ace, are you good with that equation? Okay, green check. Anyone else ready to move on? Give me a red X if you're still trying to figure this out. Okay, and if you're not giving me a red X and you want to come back to this later, y'all, just one green check is fine. We are welcome to spend more time on this. I'll put it on another whiteboard and we can do it slower or whatever you all need. But we're almost done here. We're on 14. I think there's 18 questions, right? Oh, 15 is kind of long though. All right, I'm gonna put this on the whiteboard too, so you guys can circle and fix. Oh, and Tahir, I'm not sure. We still, last time I checked, it's been several years since I looked. Last time we checked, they had cooled stuff down to like 0.00017 degrees Kelvin. Let's see what they've gotten here. So it says here, scientists at an Italian institute in New Delhi have a record of the lowest temperature ever achieved, negative 273.114 degrees Celsius. Absolute zero is negative 273.15. So they are 0.006 degrees above absolute zero. That's pretty cold. Pretty cold. Okay, so we've got one wrong on the board. To try to be the first to reach that lowest temperature. And we might find the cure for cancer by getting these cold temperatures. Yeah, first you do science just to be scientific and to make discoveries. And then people come along and they find the applications that can make our lives better. All right, so Zuleika thinks that A is not right. Anyone else want to agree or disagree with her? Yeah, anything above absolute zero, the atoms are still moving. They're still moving. So that one is actually true. And that goes right with C that says solid particles do not vibrate. That one is false. So how can we fix C to make it true? Well, Kahir, I want you to be able to think critically about these things. I want you to be able to think critically and get into that scientific mindset. Right, the only temperature where everything can stop moving is at absolute zero. The particles do vibrate. Right, so that would be the correct, the fix for C, because C says solid particles do not vibrate, and then you want to fix that by saying that they do vibrate. And then there was a fix for D, already went by, and I forgot to read it out loud. Where is it? Yeah, you were right. Okay, let me go back. Oh, every time y'all type something in, it pulls me to the bottom and I can't go back to see. What was it? I think they said tearing paper into little pieces is a physical change. I think that's what you all said. Oops. Okay, so let me go back up here. Yeah, Skylar. Hey, y'all can unpin the chat. There's that little like pin button in the side, and you can unpin it and make it big so that you can read a good bit at the time. So that's what I picked here, that it's a physical change, or you can put is not. There's lots of ways you can fix these. Yeah, if your jet freezes. Okay, on to number 15, part E, F, G, and H. Let me put that down on the whiteboard. Oh no, no, there it is. So E, F, G is true. You might have to scroll down to see H. You know, we posted out the review sheet. They are all true. But we made the review sheet as a group, and we posted it out when we were happy with it. And then I went to make the key. I'm like, oh my, there are so many truths in here. They're going to think something's wrong. And I was right. So that was just another fluke that those were all, there's so many truths. But, you know, I kind of want you to read something and get the correct information through your brain. I don't want you to read a bunch of false information. Anyway, 16. Thank you, Zuleika and Emily. Thank you, Skylar and Jasmine. Anyone else want to agree? Anyone want to disagree? I like the liquid cat. All right. We're going with C. That is the correct answer. All right, number 17. Oh, let me find my PowerPoint. Just got the information about this frozen thing. Or this on the right, I watched a show about them building this water collection system. Oh, 17. You only see 15. Let me refresh my my layout. Maybe it's not switching back and forth for you. Oh, yeah, glitchy, glitchy. Do you see 17 now? Okay, yeah, I guess I was switching back and forth between the whiteboard and my PowerPoint, and maybe you weren't switching with me. But this Warka water tower, they're working on getting fresh water to villages in Africa, and these are made out of materials that they can collect right where they live. It's quite incredible. As far as I know, they just have them as this the first one. I don't know if they built more, but that was the plan. And this solid thing, where is it? This pouring an ice cube is using super cooled water. And so it's actually below the freezing point, but it's kept liquid, and I forget how you make that. But then once you agitate it, it freezes right up, so you can pour it into the liquid. So pretty interesting things. I thought we needed a little brain break here before we finish up. So what do you think for 17A? During condensation and freezing, the materials, do they absorb or release energy? Or condensation and freezing, they're going to a lower energy state, right? So they must have released it, right? And the temperature is going to go down. Whenever you condensate and freeze something, you're losing energy. And then actually the temperature shouldn't go up or down. It should stay the same when you're doing a change of state. The freezy thing, it's just a GIF I found. I can't read what it says. AT Bristol, I think. I don't know if that's it or not, but that's, I think, what it says on the screen there. Yeah, I'm thinking the temperature should stay the same. Nah, these are just GIFs. The temperature should stay the same. That's wrong. Ugh. Ugh, let me cross that out. Same. How did we miss that? How did I miss that? There's another choice. Oh, okay. Oh, well. I'm going to quit annotating because I want you to see these are also GIFs. But yeah, that temperature, that's not right. This is it stays the same. Yeah, anytime you're changing a state, the temperature is going to stay the same while you're changing the state. I'm going to have to change this and reload the whole thing. It's all right. I'll have to let my group know that too. They've been reviewing all day. All right, so during melting and boiling, the material, does it absorb or release energy? Anyone want to agree or disagree? Right, it's going to pull energy in, and the energy, like it's taking the energy from this flame here, and it's causing the solid to turn into a liquid. It's pulling the particles apart. But the temperature, and we'll see this in just a sec on the heating and cooling diagram, the temperature as it's melting is going to stay the same. All the energy you're putting in there is just to pull the particles apart and turn them from a solid into a liquid. I'm going to have to fix that. If you are in a change of state like this, and you are here where it's boiling or condensing, the temperature stays the same. Oh, gear and refresh. So anytime you're changing your state, you have these horizontal lines on the heating curve, and you're going to have the same temperature. I'll let Canvas know. They're going to send me something to ping my computer to see if it's me or my connection. Try logging out. Sure, Ace. They should be sending Chromebooks. They're sending out like hundreds of Chromebooks every week. And so they're sending them first to those who don't have any computer, and then they're sending those that have the oldest computers. And if you have a question about your Chromebook, then you want to direct that to your FSL, because your FSL is the one who is able to request a computer for you, a Chromebook. Well, Via, check with your FSL, and hopefully, well, I don't know. You know, they're very busy, and, you know, if they're not getting back to you, just let me know and I'll check with them, because I never seem to have that problem. They always seem to get back to me really, really fast. So please let me know if they're not responding to you. Let me know and I'll see if they'll respond to me. They have lots of families, each liaison. Oh, there's the Instant Ice link. Thank you, Via. Okay, let's get back on track here. 18A, phase changes occur when the temperature is? And Ariel's going with constant. And my constant. Ace is Ariel. Constant is correct. And you can see that because these lines are horizontal. Okay, B, which interval shows ice melting? B to C, is that ice melting, guys? What do y'all think? Ooh, Gabriel's going with A to B. A to B. Now we just mentioned that phase changes occur when the temperature is constant, right? So those are going to be our horizontal lines, are going to be our phase changes. So it's either going to be BC or DE. So during the AB, you are heating up a solid, right? You're heating up a solid, and then from B to C, the solid is turning into a liquid. And then from C to D, it's a liquid and it's heating up. So B was correct, B to C. So that's what most of you guys put there. Oh, and I just answered C also. What was I thinking? Let's see if you were paying attention. During which interval is it liquid water? In which interval is the water liquid? Should have been better. Got grammar issues on that one. Yes, C to D. So there we go. Constant for the temp. B to C for ice melting. C to D for liquid water. All right, and what phase is happening between E and D? So now we're going to the left. E to D. All right, do you guys want to agree with Ace or disagree? This is liquid to gas. E to D, gas to liquid. And what's that called? What's the change of state called? And think about, this is a good one, like with your, if you have ice water in here and then you have gas molecules and they condense on the outside, that's turning from a gas into a liquid. Yeah, I know, I was just seeing if anyone would agree or disagree with you. Well, one of these days I'll bring ice water. I don't like to drink ice water because it's cold and my teeth are sensitive. But then you'll get the condensation on the outside where it was a gas and it turned into a liquid. But for science, I could definitely get some ice in there one of these days. All right, A to B, kinetic or potential energy increasing from A to B. Yes, yes, kinetic because it's moving faster. The temperature is going up. And from B to C, what kind of energy is increasing? Yes, the potential energy is increasing. All right, so we have made it to the end. And Kaher, is that in time for chorus? Well, I'd rather, since I knew we had an hour and a half, I wanted to make sure we spent enough time talking about anything. So we do have a little bit time left. First of all, just give me a 1, 2, 3, 4 on how you're going, how you're feeling about this. And I'm going to edit my assets so you can take a look at that one. Ooh, a 5. I like that. And guys, if you're not up to a 3 yet and you want some more, you have some more questions, you're welcome to call me all morning tomorrow. I have nothing on my schedule that's live. So you are welcome to call me tomorrow. And I did want to mention here that there are quizzes that we made for you reviewing. There's a Quizlet. Someone had asked about Quizlet. I made the Quizlet. We've got 3 Kahoots that you can challenge. And then I found this today to practice with the protons, electrons, and neutrons. And so all of those are available. I was probably going to reset. And I have just made the PowerPoint available on your whiteboard. So if you click those 3 little dots on your whiteboard and go to My Presentations, this one should be available for you to page through on the whiteboard. And all of these links except the last one are in your announcements and also in a review page in the modules. And then you still have to submit the study guide so I can check that you actually put the answers in there. And you should hang out. And if you have some time for review to do some of these or go through the PowerPoint and make sure it's all in order. But the rest of the time we have today is just some work time. Oh, you're welcome, Sky. See you again soon. Definitely. Hey, guys, I will be at Piedmont Park on September 25th. So I do expect to see some of you guys there. And I'm going to go ahead and